Good day, everybody. And once again, we're back together. All right, so we are still continuing on that technical science, right? Paper 1 from November 2024. So please, if you haven't subscribed, make sure you're part of the family. All right, and we are going to be continuing with this. Let's get into question 2. So they say, after experiencing a breakdown, car A of mass 950 kilograms is towed by Bucky B of mass 1,300 kilograms. The two vehicles are linked using an inextensible. Now, note this is very important. Inextensible tow bar simply tells us that the force that will be exerted there will actually, in fact, it's a rigid bar, so it means that the acceleration of the two cars will be exactly the same, right? So in this case, they say a tow bar of negligible mass as shown in the diagram. Now, they say the bucky and the car move at constant velocity. Very important again for us to highlight. Remember, what does it mean when we've got constant velocity? It simply means that our acceleration is going to be 0 meters per second squared, but it also means that the net force will also be equal to 0, right? Remember, F net is equals to ma. If A is 0, then it means net force is also 0, right? And they say, and the applied, and the force applied by the engine of the bucky is 9,000 newtons. Now, they say, name and state the law that explains why the tension experienced by both the car and the bucky have got the same magnitude, right? So we're looking at that tension over there, right? Why does it have the same magnitude? Well, that's Newton's third law, okay? That's Newton's third law. And what does it state? It says if body A exerts a force on body B, then body B will exert an equal but opposite force on body A, right? So that is a very important law for you to remember. So they say to us, draw a labeled free body diagram showing all forces acting on the bucky. Right, now let's go for it. Okay, so what are the forces acting on the bucky? I'm going to have, okay, so firstly they said to me, I've got the applied force there, okay, or the force of the engine, force of the engine. All right, and please try and make sure that you can actually show which are the forces or which of the forces are bigger. So that would be the tension on the string. Okay. And I also would have friction. Okay, I'm just trying as much as possible. Right, so please just make the dot a little bit bigger. Okay, let me do this. Let me say frictional force. And we've got tension. Right, but what other forces do we have? We've got the normal force, because the bucky is sitting on a surface, as well as gravitational force. Or you can say the weight. Right, so this is how the cookie crumbles. Those are the forces that are acting in that case. But when we consider the acceleration of the bucky or its movement horizontally, these are the forces that we're going to consider in that case, right? Okay, so let's go for it. They say to us, define the term frictional force. Remember that when we talk about friction, it is a force that is parallel to the motion of the object that opposes the motion. Okay, now let's go to the next point. They say to us the coefficient of kinetic friction, okay, between the road surface and the tires. Okay, let me just remove this part here so that it doesn't disturb us. Between the road surface and the tires of the bucky, right, is 0.45. They say calculate the magnitude of the tension in the tow bar. All right, now let's go for it, guys. So we're looking at the bucky, right? And in this case, they gave us the coefficient of friction. So we know that F net is going to be equal to ma. But remember, we said that the acceleration is 0, right? So which means when we look at the tension, now I'm going to consider the direction of motion of the tow truck to be positive, right? So what are the forces that are acting? It's going to be the force of the engine, or you can say applied force, minus the frictional force, okay? And this is minus the tension. And this would give us mass multiplied by acceleration, but we know our acceleration is 0. Right, now we were given the, or rather the bucky, the engine, the force of the engine, that was 9,000, minus friction. Now please, I want you to note, guys, when we look at the frictional force in this case, remember that friction is equal to coefficient multiplied by the normal force. Now when I look at my coefficient, they did say this is 0.45. And what is the value of my normal force in this case? It means now there are two forces that are opposing each other vertically, right? That's going to be the normal force, right, being opposed, or rather opposing the gravitational force. But what's the gravitational force of the bucky? So that would be the mass multiplied by the gravitational acceleration. So the mass of the bucky is 1,003. So that's 1,300 multiplied by 9.8. And that is how we're going to get the frictional force. So our frictional force would be 0.45 multiplied by 1,300 times 9.8. And this is minus the tension, which is exactly what we were being asked to calculate. And this is equal to 0. Right, if we take t to the other side, all that we'll be left with is 9,000 minus 0.45 times 1,300 times 9.8. And we get a value for tension, which is 3,267 newtons. All right, and that is really how the cookie crumbles in this case. That's how we're going to get our value for the tension. And then let's go on to the next one. They say to us, the tow bar suddenly becomes detached, okay, from the car while the vehicles are still in motion. The coefficient of friction between the road surface and the tires is 0.35, okay? Right. So they say explain what happens to the car after the tow bar has become detached. Right, what will happen to the car? It will continue to move forward, but remember that friction will actually get the better of it. All right, so which means that it will slow down. So the car will slow down, okay, until it stops. Right, until it stops. Okay, right, and then let's go to the last question. They say calculate the magnitude of the acceleration of the car during this motion. So now we are looking at the car. So I want you to keep in mind, guys, that remember, the acceleration of the car is no longer 0, okay? Because what we've done is that we've changed things a bit so that the acceleration, or rather so that the net force is no longer what it used to be, right? So when we look at the car, what are the forces that are acting on the car? It means it would be friction opposing. It means it would be the normal force. as well as gravitational force. Sorry about those smaller forces. I don't have as much space. Okay, right, now horizontally, what is dictating the motion of the car? It's the frictional force. Okay, so that is what is causing the car to slow down. So we're going to say F net is equal to MA. Right, and what is our net force? That's going to be friction, okay, is equal to MA. But we remember friction is 0.35, that's coefficient, multiplied by the normal force, right? Our normal force would be the mass of the car, 950 times 9.8, and this is equal to, now please note, almost forgot this, right? I considered the motion of the car to be positive, so which means in this case that the frictional force would be negative, right? It's opposing the motion, and this is equal to 950 times the acceleration. Okay, and let's quickly have a look at it. That's negative 0.35 times 9.8 times 950, and I get negative 3258.5, which is equal to 950 A. And if I divide that by 950, I get A, the acceleration, to be negative 3.43 meters per second squared. Now, why would I get negative acceleration? Because it's telling me that I'm accelerating, right, at 3.43 meters per second squared in the opposite direction. It means the car is slowing down. Okay. Right. So that is truly how the cookie crumbles, ladies and gents. I hope that you got that. Right. So I am going to leave it here for this question. We're going to be touching on more questions next time when we do question number 3. For now, I will see you guys again next time. Sharp, sharp.